Okay, good morning to everyone. Good afternoon, good evening, wherever you might be joining from. It is my honor and pleasure to welcome each and every one of us to this first edition of C2S webinar in the year 2025. I believe we are all set for a very remarkable experience. While we try to wait for others to join, for those of us who are already online, can you kindly maybe use the chats and try to type your name, where you're joining from. Let's try to meet ourselves and know where each and every one of us are joining from. We have a presenter already in the house, and I believe we are all set for a remarkable experience today. So I will check through the chat box and then which country are you joining from, your name, your institution. Let's quickly do that as much as we can. Okay. Good morning, Dr. Rita. Yes, I can see you online. Dr. Rita is a co-host on this platform. She's from Covenant University in Ogun State. Thank you, Dr. Rita. You are most welcome. You are most welcome. You are most welcome. My own name is Professor Akinlola Yinka, the founder of the Center for Computational Science, Limited by Guarantee. And then I'm a professor of physics at Edo State University, Uzare, Nigeria. I'm currently serving by the grace of God as the Dean of the Faculty of Science. Okay, I have Kubere Emumejaye. Pardon me if I didn't pronounce the name well. I believe you're a professor, you're a doctor. You are most welcome. We would like to know your institution as well. Let's have the institution, the institution where you work. It will also help us. If you are a student, you can indicate PhD students, Covenant University, Edo State University. It will be great for us to have some of our details. Okay, I have a presenter is joining from the United States of America. That is Jeffrey. You are most recognized. You're welcome. Thank you for honoring our invitation. We will soon get to meet our presenter very shortly. Okay, I'll wait for 2 more minutes for this call to order. Okay, thank you, sir. Dr. Kubere from Delta State University of Science and Technology, Ozoro. You are most welcome, sir. I have Adewopo Adeniyi, Professor Doctor, please pardon me, Department of Physics, Lagos State University of Education. Oh, Ijanikin, Lagos. Thank you, sir. You are most welcome. You are recognized, sir. So I have Abraham Ponra from Cameroon. Oh, you are most welcome. It's an honor to have you around. God bless you. I have Dr. Isaiah Igwe, Federal University, Osima. You are most welcome, sir. It's an honor to have you around, and I believe we will have a very engaging and refreshing experience learning together this morning. Thank you, thank you. Good morning. So I have Leonard from Addis Ababa University, master student in computational material science, AAU Ethiopia. Okay, he's a Nigerian. You are most welcome, Mr. Leonard. It's an honor to have you on this platform, and I believe we'll work together to achieve our respective objectives. Thank you so much. It's an honor to have you around. Okay, without taking much of our time, maybe as I have more names, I may quickly flip through them. But in the meantime, I would quickly like to share with us what the experience today will look like. Very quickly. I believe you can see my screen. So this is the first edition of this webinar. For those who might be joining us for the first time, we started this webinar series sometimes mid last year, and then we were able to hold the event successfully throughout last year, covering concepts of using a quantum mobile on a Windows system, as in creating a virtual operating system within which you can actually carry out some computation simulations using Quantum Espresso. We delved deep into band structure calculation and so many other properties. It was a very worthwhile experience for us. This year, our mandate and our direction is in consolidating on what we've been able to achieve last year. We discover we need knowledge of Python programming, especially as we'll be looking at the application of AI and machine learning in material simulation and modeling. So we discover the knowledge of Python, at least at its basic level, will be very necessary for every participant to be able to actually flow along. It is in the spirit of this that we are starting this first 2 months of the year with hands-on and then a practical in-depth knowledge of Python programming. And we have an expert from the United States of America who will actually be helping us in this. So I believe we are all set for very refreshing experience even as we go through. Those who are just joining, you can just help us by introducing yourself on the chat so that we can quickly recognize you. And so that's what we'll be doing for the first 2 months of this year by the grace of God. And so the outline of today's event is as follows. Informality, we are already going through that. After that, I will take a short citation of the presenter, and thereafter, we go into the presentation. After the presentation, then I will go through a little brief about PhET interactive simulation. Why are we going to talk about PhET interactive simulation? If you look at the poster of this event, you will discover part of the sponsor that I enlisted here is PhET interactive simulation, pronounced as PhET, and is located at University of Colorado Boulder. This Zoom platform is provided by that organization, by that establishment, and so it is also expedient for us to actually let us know, or let each and every one of you know, what do they stand for and how can we benefit from what the institution offer. And so I'm a fellow of PhET, and then I'm proud to say that a little intro will be handled by myself on that. And thereafter, we will have a hands-on session, question and answer, an interactive session on how we can actually go about Python programming. Remember, in our call for registration, we have asked and advised everybody to download and install Anaconda. Even if you have not done so, I believe before the end of today's interaction, definitely you would have been able to have the opportunity to do that one and master the use of Python, at least at its basic level, by the end of today, by God's grace. So, having said that, I'll quickly go to the citation of our respected speaker, who is here to impart us with some of the knowledge. And he is no other person than Jeffrey Voke Ojuederi. Who is Jeffrey? Okay. Mr. Jeff, if you don't mind, you can also share your live video since you are online, so I don't have to use your picture. Okay. So let me see if I can spotlight you for people to actually see you. Okay, so it doesn't have to be my, okay, so Jeffrey is spotlighted for everybody to see. Okay, now, that's the man that will be taking us through the concept we are discussing this morning. Who is this man? Our speaker today is no other person than Jeffrey Foke Ojuederi. He's a distinguished full-stack scientist at Photon 3 with a unique blend of physics, mathematics, and advanced programming experience. Jeffrey is a graduate of Benson Idahosa University with a remarkable bachelor. In fact, not just a bachelor, he has a double honors in both physics and mathematics. Jeffrey graduated in Benson Idahosa University with an exceptional CGPA of 4.98 out of 5. I think he deserves a round of applause. You may do it electronically, that is allowed. Okay? Now, Jeffrey also holds a dual master degree from Ut International Business School in Business and Finance, and is set for his PhD at Yale University in the next couple of months by the grace of God. With over 6 years of experience implementing complex computational solutions, Jeffrey has led significant projects across various Fortune 500 companies, including Vanguard Group and Gap Incorporated in the United States of America. His expertise spans across quantum computing, machine learning, deep learning, and even AI frameworks, making him particularly well suited to bridge the gap between theoretical physics and practical programming applications. He has vast experience in large language-based solutions like the ChatGPT and the rest of them. And he is also maintaining a regular workshop across various employees and employers within outside United States of America. His current work at Photon 3 involves developing sophisticated algorithms and scaling complex computational models. Today, we are privileged to have Jeffrey, who will be sharing his insight on leveraging Python for quantum physics applications. Drawing from his strong foundation in both theoretical physics and practical program implementation, I believe no other person can do justice to the topic we have before us other than Jeffrey. This morning, I present to you our presenter, Jeffrey Voke Ojuediri. You are most welcome. Now over to you.
Oh, good morning, sir. Just confirming everyone can hear me, please.
Yes, we can.
Okay, fantastic. Good morning, sir. Good morning, everyone. Good evening to some of us, afternoon, wherever we might be. So we're going to start the first of at least two series on understanding how we can leverage Python for quantum physics use cases. I would share my screen real quick so we get a chance to see what's going on. And just kindly let me know if and when you can see my screen.
Yes, we can see.
Okay. Now, when it comes to, I think just reading through everyone's background and discipline, I get a sense that a lot of us are very exposed to a good amount of abstract concepts, different layers of complexities with our disciplines and the kind of work that we are involved in. So this might not be very foreign, but even if it's foreign, and even if there's a steep learning curve, we'll just kind of go through it as quick as we can, but also try to leverage some practical work as well, like hands-on experience, hands-on sessions. I think that would benefit us the most. So let's get right into it. I think crucial attend that has been addressed. We're going to look at why Python. There are other languages out there, C++, MATLAB, R, Julia. There's even a relatively new programming language called Rust. These are all very great programming languages, but while we're focusing on Python, for example, um, we'll kind of go through that on a high level, discuss, how to set up your Python IDs, so your integrated development environment, to one, best help you run Python programs, but also help with, consistent development, continuous integrations, and all of that around building, the projects that you're building. And we'll kind of look at how we can leverage some Python basics for basic quantum physics problems and, simulating basic quantum phenomena, I should say. Um, Everyone here, I believe you have a level of interest in quantum simulations. If you see me looking this way, I have another screen here, so I'm not distracted. I'm just looking through my slides. Um, I'm sure we're interested in quantum simulations, data analytics, machine learning, quantum computing, with varying interests, I should say. Um, oh, I see someone who's trying to join in. Am I supposed to let them admit them?
No, no, no. I'll do that. I'll do that. You
Okay,
just go.
okay. Yeah, so we all have like varying interests, and it's so beautiful to have those. Python lends itself very useful to solving all these kind of computational problems. Um, Imagine if you had to do this manually. I'm sure if you've done some kind of applied mathematics problems, you realize that in the real world, it's hard to have um, solutions that are not approximations, right? That's why we need things like numerical integrations and numerical methods. Python helps us to at least scale those in with very large data sets, very large use cases, diverse use cases, lending all kinds of libraries that we can use to accomplish that. Python is relatively simple to use compared to like languages like C++ that can be very difficult and have like a learning curve. So although Python might not be as fast as C++, it's very simple to use, very versatile, and it's free. Like think about that. You have thousands of libraries that you could use for different use cases. Um, I'm sure the proliferation of machine learning and AI is not foreign to anyone here. So based on that, you understand that Python lends itself very useful to all kinds of simulations, all kinds of modeling, scenario analysis, visualization, all kinds of analytics that you could think of, while doing that with very limited um, required hardware. So you don't necessarily have to build supercomputers at home to run Python programs for different analytics. Now, the caveat to that is Python might not be as fast. So it's important to master the language as much as you can to make your code as computationally efficient as possible. Um, One might ask, okay, I'm sure you have to run simulations for extremely large data sets and big data. How then does Python lend itself useful? Python has a lot of libraries like PySpark. So that's like Python merging with Apache Spark to run a lot of like big data analysis on large data sets. So it helps to, speed up the process of your programming and all that. Um, Helps to run your analysis quickly without having to worry about a whole bunch of like laptop specifications. So you could have like GPUs access through that library as well. And like I said, thousands of Python packages and all that. Now, let's step back for a second and think about this. Um, let's say you wanted to, you had some interest in understanding, let's say in somewhere in South Africa, what kind of animals are being poached, what animals are likely to be poached, and where poachers are likely to be to actually kill these animals. This is a relatively complex problem to deal with, um, because if you're going to do something that is data driven, you need a lot of data first to analyze, to build a model, and then so you get your data, you build your model, you test the model, you deploy it, and then see how it's reacting in real time to get a sense of its latency, its usefulness, and how it actually judges reality. All of those things can be done without understanding machine learning methodologies, AI techniques, machine learning frameworks, data pipelines, um, concepts that scale from complex to extremely complex. The last thing you want to do is trying to walk through a language that is already super complex to solve problems that are already very complex. Um, in that kind of scenario that has potential for great return and great usefulness with pristine use case, Python is your guy. Yeah, Python is your guy. So imagine your own kind of use case that you have to deal with. I see someone who is a master's student in computational material science. There's so many libraries within Python that you can leverage for all kinds of use cases that you might have. Whether you're in biomedical sciences, whether you're in engineering, there's so many use cases. And so for me, my bias is always towards Python. Now, how do we set up a Python environment? I'm going to talk for quite some time and then focus most of our attention on the actual practicals. There are different integrated development environments that you can use. VS Code, to me, VS Code and Anacondas are kind of like top class for me. VS Code makes it very easy for you to um, quickly get connected to GitHub, where you can consistently upgrade and update your projects. Um, Helps with quick deployments. It makes it easier for collaboration and is very lightweight. That's something that's very beautiful about it. If you're doing any kind of data analysis, data science, machine learning, Anacondas has a whole bunch of libraries built in that makes it very easy, to run your analysis. So within Anacondas, you have the basic pandas, NumPy, SciPy. Then if you're doing things a bit more advanced, you have your scikit-learn, PyTorch. So these are some libraries that you need. So it's paramount that you have Anacondas installed, you have VS Code or PyCharm. PyCharm is relatively good, but their professional version is not free. But VS Code and Anacondas Anacondas are both free. So um, my suggestion is have VS Code and Anacondas installed. That is where you now get to install your Python um, execution package with essential libraries that you need. So the order work is you have to install your IDE and then you have to install Python and the essential libraries. I would pause for a second to see if everyone has or anyone has a question. You could put that in the chat before I move forward. So I'm just trying to set the foundation before we move on. If there, I'll give like 30 seconds. If there are no questions, I would proceed. What is the major difference between Anaconda and Miniconda? In my experience, Miniconda is almost like an approximation of Anaconda. Anaconda is a lot more common, is a lot more robust, and has it's a heavy package that has pretty much everything that you need. I know Miniconda has a lot of limitations that Anaconda doesn't. So I think about Miniconda as a subset of Anaconda. That's a great question, by the way. I don't know if that's clear or if you want me to expatiate on that.
That's
To
correct.
me, okay, if you want to choose between either of the two, definitely focus on Anaconda instead of Miniconda. Yes. What ID will you recommend? I absolutely will recommend VS Code. That's what I use personally, and that's what I've been using for years. I would assume that you're going to work on projects where you have to collaborate with, peers, superiors, and um, otherwise, VS Code makes it easy for collaboration. Like I said, makes it easy for you to deploy your codes, both privately or publicly, whether through Docker or some kind of containerized application, or within GitHub, GitLab, or whatever the case would be. So VS Code is lightweight, it's free. Yeah. Yeah, you could install both of them and then run Anacondas through VS Code. Yeah, you could also install Anaconda on its own and then run Jupyter Notebook within Anaconda. Within VS Code, you can run Jupyter while running the specific Python package that you have running within Anacondas. So again, we can kind of practically go through that if that hasn't been done yet. And just before we even get there, expect a lot of error messages. It doesn't mean you're terrible. It doesn't mean you don't know what you're doing. It's part of the process, professional and otherwise. Everyone gets error messages. Yeah, so I
Agreed.
see that Professor just put the link to downloading VS Code. So you could download it. We could set you up, and everyone gets errors. So it doesn't make you seem like terrible and you don't know what you're doing. Some of the Python basics that we need as foundations to do anything would be, sorry, let me quickly fix this in a way that would be helpful. Okay, we need to definitely look into the concept of variables and data types. You can't be a great data analyst or analyze data if you don't understand data types and the limitations of each data type, the strength and limitations of each. Um, Loops and conditionals. A lot of times when you're doing your analysis, you have to run something 1,000 times, or you have to run something till a specific condition is met. Um, so you need to understand loops. Conditions is just like when you solve mathematical problems and you're trying to essentially leverage different kinds of logic. I'm sure some of us are familiar with the logic tables and um, argument constructions. Those things kind of ring true here when you're building logics and or and all of those beautiful things. Nothing complex. We can always dig through those step by step. What do I have there? Functions. Functions make it super easy to run. Like, you know what? Function does a whole lot, but one of the things I'll say, functions make your code look cleaner too. It makes it easy to run a bunch of redundant tasks all at once. Um, Again, all of this might sound foreign, but when we go through it, it'll become a lot clearer. I think I'm looking at the chat. Okay. Importing libraries. If you don't know how to import libraries, you wouldn't be able to do a whole lot. It, a lot of these libraries are already in place. A lot of the hard work has been done to have these libraries um, available for us to use. So a lot of times you don't have to build things from scratch, right? So it's very essential that you understand how to import libraries, how to import packages, and how to leverage sub packages within libraries. Um, these are the basic Python data types. I know we can look at the screen, so I'm going to give us a second to kind of look through what we're seeing on the screen, and then I'll delve into it. Just a quick second to look into it. This is what I would suggest we'll get our notes and probably write some things down. Um, if you want this slide specifically, or you want like extra information, I have some extra information. I have some texts that can help. Um, the book is already bought. I have it in the soft copy. I would share it with Professor, and Professor will share it with all of us if we want. Basically, would walk you through the basic of Python for quantum physics, quantum computing. I have two of those, all the way to building machine learning algorithms um, within Python. So if you want that, I would share that with Professor after this call, and then we can leverage that. So just kindly let Professor know, and would have those books ready. Books are already bought, and you don't have to pay anything to have them. Okay, so basic data types, numeric, that essentially explains itself. You have integers, floats. So floats is another word for like decimal numbers, decimal number types, or decimal values. Um, so you have something like zero point 0.5, 0.1, 0.3. That's what we describe as floats. Integers are integers. Yeah, from negative to positive, negative 10, 10, 5, 7. I'm not saying we don't know these things, but I'm just doing my due diligence, right? Um, what does this data type mean? Essentially handles numeric values. Any value that's a number falls on that data type, numeric. Boolean is another way of saying true or false, zeros and ones. Um, yeah, on and off. When we have quantum superposition, quantum state 0 and 1, this falls within um, Boolean. Uh, String, that's what we, before I even go there, that's what we'll see a major difference between conventional, or what we call classical computing and quantum computing. Just very basic, when it comes to quantum physics, the basic difference between states is for classicals, we only exist between 0 and 1. For quantum, you can exist in multiple states and permutations of zeros and ones. So that's where you see packages like qubit lending itself useful for true and false situations, as opposed to classicals where we just have true or false, right? So Boolean is just true or false, but when we get into quantum computing, you see situations where you can handle superpositions. Strings are, think about it as words. Anything that has quotation mark on them is a string. So even if you have the number 2 and you put quotation marks, it's a string. Even if it's numeric and you put a quotation mark, it's a string. Words generally would classify as strings. But whenever you have characters that have quotation, whether it's double quotation or single quotation, those are strings. There's so many things I can do with those. If I start explaining them, it becomes a bit more abstract. But think about a situation where I want to count the number of letters in the string in a word, or the number of words in a sentence. These are different operations that you can do with Python in a string, for example. I don't know if you guys have seen some of these LLMs that helps you summarize um, texts, helps answer questions from texts. So essentially, you feed it like a publication, and then you ask questions based on that publication that you fed the LLM, and then it gives all the answers that you need. The basic is understanding natural language processing, and then the basics of natural language processing is string construction, characters, words, and all of that. Um, is a very interesting area that maybe at some point we can look into. But the materials that we send would have those lists, also like a list, a collection of items. So a collection of words in a square bracket is a list. A collection of numbers is a list. I see things in the chat. Okay, just making sure. A collection of letters is a list. So just items. Tuples, a bit similar to lists, but have different kind of operations. Lists are mutable, means you can go and change what is in a specific list. Tuples, not necessarily. You can't necessarily do that. They're immutable. Sets are usually like collections of unique items, just the same logic that we have in set theory and things like that. Dictionaries hold what we call key value pair combinations. So if I have, let's think about it. Let's use this call, for example. Um, let's say we have a variable A, and then we're looking at everyone who is in Nigeria, and we're doing a count of that. The key would be A, which is everyone in Nigeria, everyone in Nigeria. Then the count of that will be the number of people that are from Nigeria, right? So the key is that the value is the count. The key is a string usually, and the value is usually an integer or a float. So that's one of the way dictionaries work. All of these things, they sound very, probably very abstract now, but it's a lot easier to digest when you're doing hands-on um, work. Now, do we have any question? Does anyone have their Python already set up? If you do, just kindly go to the chat. If you have your Python set up, let's jump right into it. I think more action, less talk. That's usually my motto. So
Okay, I have a
okay.
yes.
Yeah, Thomas has his. Sweet.
Okay, Professor Lokmade, yeah, that's great.
Oh,
Okay,
sweet.
like he's raising his hand. Oh, you can mute yourself if you have to speak.
Okay.
Yes, I have downloaded and installed the well, it was Anaconda that you sent that I installed.
Okay, great, great, great.
I installed the
Okay,
That
Anaconda.
works too. That
that
works
works.
too. That works too, for sure. Um, okay, if you don't have your setup, I know the links are there. Have you been able to download Anaconda or VS Code? Anaconda will be a lot easier for you to actually download and set up within our time frame.
Now, I think VS Code is smaller. The only constraint you will have there is the libraries you have access to. Okay,
Yeah,
like Miniconda that somebody was asking earlier is about 400 MB. But a typical Anaconda could be as much as 3 gig or even or a little less.
that
So
would
that's it.
Anaconda is about 900 megabytes.
Yes, after installing, then you to get it to take up to about maybe 300 or 2 point something gig on your
yes, sir.
drive.
Yes, sir.
So
Yes, sir.
please, if you can quickly install that, that will be great for us, so that we can really have the hands-on experience. That will
Yeah,
really be good for us.
yeah.
So maybe I think we can take a break of like 10 minutes for
Okay.
everybody to get that done. Okay, someone is
Yeah.
asking a question here.
I installed Python
Yes, I
3
installed
along.
Python along Quantum Espresso. I don't know if it works. If you can give us more explanation on how you install it, because this time around, we are not thinking of working within a Quantum mobile, because it's better if you're using a Windows operating system, have your Anaconda installed directly on your Windows operating system. Or if you're using Linux, have it installed directly, not on a Quantum mobile, okay, being a virtual machine. So that's what we advise for now. So I think on the immediate, let's advise everybody to run with Anaconda for now. Maybe subsequently, we
Yeah,
can begin to look at a VS Code. I have the two install my own system. That's why I said, if you also have the time, you can install the two. You are losing nothing. Okay?
yeah, yeah. Let me see. I don't know if you can see my VS Code screen, sir.
Yes, yes, we can.
Okay. So I'm just going to give another 1 minute, some time for people to get themselves set up, and then would jump right into it.
Yeah.
And you can use anything from Python 3.9 to, I would suggest, end at 3.12 because you might have some library dependency issues. Once you
Yeah.
pass 3.12, yeah, you need to give it time. Um,
Is it Anaconda that you opened?
No, that's
no,
VS
sir.
Code.
This is VS Code.
Okay.
Okay.
Yeah,
If you want to, okay, let me give a brief guide. If you want
okay.
to launch your own Anaconda, or those who have installed. All you have to do is to go through your start menu and look for Anaconda. You will see Anaconda prompts. I will always prefer to go through Anaconda prompts and not through the navigator.
Anaconda prompt, okay.
Yeah, so click Anaconda prompts and then simply on the terminal. Now, okay, you have your prompts. You have your prompts terminal coming up.
Yes.
And by default, you will be in your user folder. Please take note of where you are on that browser. I'll be on that terminal. You have your C users and then your username. Nowhere that, because if you log in from here, this is where all your Python code you eventually create will be stored, except to navigate otherwise when you get to the Jupyter notebook. Is that noted?
Yes, it's noted.
Okay. Next is just to type Jupyter space LAB. JPUTERLAB.
Space
LAB, Jupyter Lab. Jupyter is JUPY.
Yeah, I just put it in the chat for them.
Okay, thanks. Thanks.
Yes,
That's great. Okay. And so with that, you will have the Jupyter notebook open in your.
it's informing Jupyter is not recognized. So is it capital or what?
Not capital. Just check what is placed on the charts.
Okay.
Check what is placed in the Zoom charts. So you can't afford to miss any of the.
Okay. I've seen that.
Okay, great.
I've seen that.
For those who are installing, please let's know how you are progressing.
yes,
Let's know if you have any challenge that we need to address. How many persons are following up with opening the Jupyter Lab?
So
Please
it's informing me. Okay. I think it says linked.
Okay.
Well, it has gone to launch.
A browser for you.
Yes.
Great. So that's the window where you'll be working. Okay.
Yeah.
So
okay.
I think let's know if other people have been able to get to that stage, please. So let's be sure you can actually launch an environment where you can work. It's very important.
I think someone has there is it saying you can't use Spider? I don't think you should use Spider for now.
Don't use Spider, please. Don't use Spider. It's Python way to me.
Yeah.
If you install Anaconda, all you have to do with Anaconda, you add Jupyter Lab.
Jupyter Lab.
You understand it now? All you have to do, open the Anaconda. I said, can you unmute yourself and speak? So let's know the specific level where you are so that we can actually discuss. That will help us. Dr. Isaiah Igwe, you can unmute yourself and let's have the conversation so that let's know where you are and that you can actually come up with your Jupyter notebook. Do we have other people who are working, please? So that let's be sure we have people we are waiting for.
Hello, sir. Good morning, sir.
Good morning.
Please, sir, I downloaded it yesterday, but I'm trying to. I can't. It's not working.
No, what's the challenge you are having? Let's know the specific challenge. Have you been able to locate the file you downloaded?
Yes, sir.
Okay, what's the file size?
2.2024.10. Windows.
No, except you didn't download the complete one. That's like 200 MB. So
Okay.
please quickly follow the link we have in the charts. and download
All right.
again. Please,
Okay, sir.
quickly follow that. Let's hope the network will be fast. You should be able to get it through. Any other person again, please? Let's have your feedback so that let's be sure.
Yes. Good
Okay.
morning. Good morning, Prof.
Good morning, sir.
Please, I'm already at the notebook, the Anaconda notebook.
Oh, awesome.
So,
Thank you.
What is the next step, sir?
And let's just hold on for our presenter. He will guide us on what to do next. You are already within the environment where you can run Python code. And I believe we will see the code here. Maybe we have to type on our own, and then let's see how we want to guide us. We are already in the environment, so let's wait for some other people to get to that environment. As any other person, please, let's have your feedback.
Abraham, I see a question. There's a link above on how to install that sends you to the Anaconda.
Okay, maybe I should share the link again. I believe most of us are on Windows. Let me see if I can get the direct link for the Windows version.
I think Omar has a question.
Okay, that's Dr. Rita.
Dr. Rita.
Yes, thank you, Prof. Thank you, Mr. Jeff, for the presentation. I just want to know why Prof is discouraging participants from, working with quantum mobile. Because the thing is that if you are still, of course, quantum mobile is a package, and there's also AIDA. And AIDA has a lot to do with most of this computation, and then you still get to do it quantum mobile. So, but I just want to know Prof's reason, because you can actually launch your computer notebook. So, Prof, is there a particular reason? Because at the end of the day, you want to use AIDA, you would still have to use Jupyter Notebook AIDA.
Thank you, Dr. Rita. Reason why we're looking at having the Python running on your window for now is to be able to have full access to system resources, especially when you don't have access to supercomputer to carry out some computationally intensive calculation. If you have to run it on a virtual machine, the resources available to the virtual machine is what will be available to the Python you are running within that virtual machine. You understand? So it's not a rule that you cannot run it there. But we are looking at a situation whereby you want to run maybe a machine learning model that requires maybe so much data or big data. If you get to that stage and you are on a virtual machine, of course, you are not using the full resources of your system. It's not available to you. What is available to you at that point in time is just what is available to that virtual machine. So that was a singular reason. So, yes. But the knowledge here can actually be transferred to actually relate with AIDA when you get to that stage. You understand? So this is just like laying the foundation. Whatever code you run here, any Python code you're able to run here, you can take it there and then implement it directly. Do you get the point, Dr. Rita?
Yes, Prof. Thank you very much, sir.
Okay, thank you. Any feedback again, please? Okay, can we have a thumb up for those who have the Anaconda running on their system for now? Let's have a thumb up for you so that let's know the number of persons who have the Anaconda running so that we can go to the hands-on. Thumb up for those from those. Okay, I have one. It's too few. I know I've gotten verbal. Okay, I have two. Okay. I know Prof. Prof also have it running. I think we should just go on to hands-on. So
Okay.
those who don't get it running at this stage, maybe maybe when they have the recording, they can actually leverage on the information, because the recording will definitely be shared. Okay.
Okay.
So after the browser is prompted using the digital lab, so where will I go next?
Now, let me quickly open my own so that I will give you the specific information on what you do. I'm trying to launch mine. Or probably maybe I should just share my screen 1 minute.
Yes, sir. Yes, sir.
I think my screen 1 minute so that we'll see what's there. Okay. Allow replace current share. I will have to override the existing screen.
Yes, sir.
Okay. Can we see the screen?
Yes.
Yes, sir.
Okay, great. So this is notebook. This is called Python notebook. And once you open this, it will create an automatic Python notebook.
No, he's asking me to create. Do I need to create an account? I don't understand.
No,
Mine
you
is
don't
not giving me this, what you have here.
Can you share
What
your screen with us then? What do you have on your screen?
I have it open the browser localhost colon 888 /lab. That is
Yes.
where I am. So it's
Yes.
now displaying Anaconda project, Anaconda 3, contact, so on and so forth, virtual MS and so on. That is what I am.
Share your screen. Share your screen. Let's see what you have on your screen.
I should share my screen. Okay.
Yeah, share your screen. Let's see it so that let's address it.
What is it? Okay. So can you see it?
Okay. You are there, Prof. This is where you are. All you have to do is to scroll up. Just scroll up here. And
Okay,
you have
okay.
so it's there.
It's there. Okay.
Yeah. And that is the location. You can see all you have your desktop, you have your document and all what have you by the left. So
By the
once,
left, yes.
yeah. So once you click this, all you have to do, once you click this, you will see a new untitled IPython file created in your left column here. And then you can begin to type your.
I should click on the Python.
Yes, click on it, Prof. Yes. Click on the
The
first one.
notebook or the
Yes.
console?
Click on that, yes.
Okay.
So you can see you have an untitled IPython notebook.
Okay.
So within that window, you can type your Python code, and then you can click the run button up there, or you use Shift Enter, run that particular cell. Okay?
Okay, thank you. So let me stop sharing.
Okay. So is there any other person again that need any clarification on being able to get to that place where you can run the Python code?
I think someone is using Ubuntu and needs help. I'll just send them this script real quick.
Let's have specific. Okay.
Yeah, using Ubuntu.
You're on Ubuntu, right? The same thing working. Okay, the link to install that. Okay, that's Anaconda. Yeah.
Yeah, they just need to run this in their terminal to get Anaconda. If you're using Linux, just paste this into your terminal.
So if you're on Linux, like those who might choose to work within Quantum Mobile, you can also install Anaconda within that environment as well. But like I mentioned earlier, the only constraint is that you have limited access to your full computer resources within a virtual environment. Okay, so you might run certain code and you might run into error. And remember, our presenter told us that Python could be computationally intensive sometimes, okay, compared to other code. So let's take note of that. So the code has been pasted, so you can copy that code for those of you who are within, copy it with wget, okay, and that will download. So after the download, you need to just run this, run the file, and then you have it installed on your system.
Yes, sir.
Is
I think there might be a bit of a network.
Ladi, can you please unmute yourself so that let's have your feedback? Feedback will help us to be able to progress better, please. Okay, so if there's no other feedback, please, I think we need to go ahead.
Okay.
So, yeah.
Let me reshare my screen again. Can we see my screen, please?
Yes,
Yes, we can.
Okay. So I'm assuming everyone here, or at least some of us here, have never made use of Python. That's a safe assumption. So we can all follow along. Probably some of the things that we'll start with here, we are all from, some of us are familiar with them. Let's just patiently go through it. It doesn't hurt to refresh our memories, right? So let's run our first Python code before we do anything. So assuming you have your Jupyter lab open, you should be able to see all these cells. Make sure at the bottom right, you see something called Python. If it's not Python, it's not going to run Python code. I'm going to give you a second to look. I'm guessing thumbs up on that. Okay, good.
Well,
Our first, yes, sir. Sorry, I missed that.
Oh, I was trying to check for the Python, but I think it's Python because what I have is IPYND.
Oh, yeah, so
Exactly.
you're good.
Good to go.
Yeah, so you're good to go. So let's do the first thing. Let's print hello world. So this is print parenthesis hello world. If you've typed it, all you need to do is press shift and enter at the same time. Let me know those who were able to run that successfully. Anyone? Okay. Awesome. I'm assuming you've used Python before, but if you haven't, congratulations, you just ran your first Python code. Is there anyone who has not been able to run it yet? Waiting, waiting, waiting. Waiting. Anyone having any issue with it? We're all learning. Trust me, if you had an error, I've had way more errors. Yeah. Okay. Let's assume everyone is following along. I would
I am
assume that.
having error.
Okay, sweet. Now let's let the fun start. What's the error that you see?
Syntax error, missing parentheses in call to print.
Okay, that's good. Let's do this. In the hello world, did you put hello world inside the parentheses? So after print,
Yes, I did.
okay, so let me see your screen real quick.
Okay.
I will stop sharing. Uh, then let me see your screen.
So that's it.
Okay, so you need to change that the kind of bracket you are using.
Okay.
So go back, yeah, go back to okay, just
this?
move your cursor to after print. Yes, that's the bracket you want to use. So change that.
Just before you run a quick one,
Okay.
if you look at your error syntax, the error message,
okay,
suggestion to correct is also there for you.
That's true.
okay. Did you mean to use this? Okay,
Exactly.
okay.
So congratulations, sir.
Thank you.
Yeah, congratulations.
That's a
So
good
let's
one.
see who else. Anyone having issues? Okay.
Okay.
So
Before you go ahead,
yes,
for
sir.
a more practical experience, maybe we can quickly introduce something that will make everybody to actually follow through.
Okay.
Making of Google Colab. So I will share a link with you very quickly.
Okay, sir.
There's a cloud resources online provided by Google.
Mm-hmm.
It's called Google Colab. So I will share that with you very quickly so that you register that you can run a Python code online just from your browser so that the experience everybody can have the experience.
Okay.
I don't know if that is okay by everyone.
No, it's okay.
Yeah, that sounds fine to me.
So then maybe before the next class, I believe everybody would have been able to get this thing running on their system. So you can quickly go through that link, authenticate yourself with your email address, and then you get, okay, I think I should just even share that screen and show you how you can go through that very quickly.
Yeah.
Let me just pick any of my browser.
Saying welcome to Colab.
Yes.
Yeah.
So,
then just essentially go to file and create a new notebook.
okay, new notebook. That's down.
Yeah.
Okay.
Can you hear me?
Can you hear me? Can you hear me? Can you hear me?
We can hear you, but there's echo.
You have background echo.
I have opened a new notebook.
Okay, you have a new notebook online now.
Yes, start coding or generate with AI.
Okay, that's a good
So
one.
just essentially do the same thing that you did in your Jupyter lab.
Exactly. Yeah.
Just print hello world. Just run it again. Yeah.
Sir Igwe, can we have your comment, please?
Yeah, sorry, no, the other time my network cut off. So I've launched Naconda using Navigator. But I tried to launch the Jupyter Lab but it's not working.
Okay. What you will do, sir? Can you share your screen with us?
Okay.
Share your screen with us so that you can receive a straight guide on how to go about it.
I have been able to do that.
Okay, awesome, Prof. That's great.
Yeah.
That's quite impressive, Prof. I love that. So, Prof, you've been able to run it on your local system, and at the same time, you've been able to run it online as well.
Online, yes.
Let me quickly add it that what you have there is actually stored in your Google Drive. You can access it anytime, any day. It's stored online there for you.
Okay.
Can you see my screen?
Okay, we can see it. Okay, you're going through the navigator. Good.
Yeah.
Now, click the very first one, Launch Jupyter Lab. You can go through this place. Yes, Launch Jupyter Lab.
Sometime now it's not launching.
Ah, there's serious echo.
Don't worry, close it. Just close the whole of this window. Oftentimes I don't go to the navigator. It's not responding. Okay, see what you will do. Just hold on, leave that one alone. Go to your start menu, type Anaconda. Go to your start menu, type Anaconda. Just click start menu. Okay, have you been able to quit it? Yes. Good. Now go to your start menu. Just click your start menu. Anaconda. We're not seeing your screen. But what you want to open is Anaconda prompts. Please look for it. Look out for it. Anaconda prompts. Anaconda prompts. That's what you're looking out for. Anaconda prompts. That's what you're looking out for. Are you still there, Dr. Isa? Dr. Isaiah?
Yeah, it's not coming up.
Yes.
Anyway, let me not delay the.
See what you will do. I will paste a message to you on how to go about it so that you can follow. I know network might be a challenge there. I will post a message to you now on how to go about it. Okay, it's there now. So click Anaconda prompts. We can see now Anaconda prompt. Click that. Good. So you have a terminal. Yes, we have a terminal. On that terminal, what we will now type is Jupyter Lab. That has been pasted on our chat earlier. Jupyter Lab. Jupyter space LAB.
There should be space.
Jupyter. Okay, it's launching, so you're good to go.
Okay. Oh yeah, it has come up.
Yeah, so you can open your first notebook. Simply click the notebook now, Python 3 IPY kernel. Just click on that. Yes, a Jupyter notebook will be open for you where you can run your code. And so that's a window where you can run your code. You can see the file on the left here. So if you go to my computer and navigate to this location, you will see this file untitled there. You can right click on it and rename it to any name. Okay, you have not typed print. Print and parentheses.
Oh.
Hello. Great. Parentheses. No, not enter. Okay. No, okay. All right. Then you can run it. Let's see, just hello. Click the arrow to run or shift enter, whichever one is okay for you. Shift enter on the keyboard, or you click the arrow key up there to run the code. Good.
All right.
You're good to go. Congratulations. You've been able to run your first code. That's awesome. Okay. That's good. Congrats, sir. Okay, any other person again with specific attention? Okay, so we can go on, Jeff.
Okay, sir.
Thank you.
So let me share my screen again.
Isaiah. Okay.
So I transitioned to the Google Colab just like the rest who did.
Okay.
So I think it would just be easy for us all to use Google Colab.
Okay. Okay.
Yeah, so I'm guessing everyone will all got into this point. So remember the first thing that we discussed that we're going to actually look at variables. Before that, how do you write comments? If you want, let's take a step back. Why would you want to write comments at all? Imagine you created a code 5 years ago and you've worked on, let's say, 500 projects since then. If you go back and look at that code, it probably doesn't mean much to you. Yeah, so comments help you and people that collaborate with you to understand what your code is doing. And beyond understanding what your code is doing, understanding why you chose to write that code in the first place. So this is how you comment. The pound key, which I believe is also called hash.
Yeah.
And then you write what you want to write. The thing is, Python doesn't run that. Python looks at it as something that is not an executable code. It's just a comment. So anything you put after the hash key doesn't count. You can even put twinkle, twinkle, little star. It wouldn't affect your code. So I'm going to call this variable. When the more we go into it, I will show you how to use the markdown or the text cell where you can actually have descriptions of what each code segment is doing. But for now, let's keep it simple. Let me know if you've been able to write that comment. Professor.
Yes.
Yeah. No, I'm talking about the other professor who's been with us. Yeah. Professor Olopade, you're with us, right?
Okay, the hash and the variable, is there a space?
You can put space, there's no need for, you can say no space, but it makes it easy to read when you have space. So yes, use space.
Okay. I have done that hash variable.
Yeah. So you could run it. If you see you run it, you get no result.
Yes.
So remember to run shift
and
enter.
I have done that.
Good. So I just want to make sure that we're on the same page. Now let's call, what we're doing here is just understanding variable creation and how to leverage variables within Python, right? So let's call one variable a equal to 1, b equal to 2, right? And then let's say c is equal to a plus b. If you run this, you're not going to get any result because you haven't told Python what to do with that last variable. Yes, you said do addition, but you didn't tell Python to return it. So remember, print helps to return whatever statement or operation that you have done within different variables. Anyone got into this point? So print that last variable called C. Okay, Thomas is right with us on every step. Thank you, sir.
See? So let me just see. Is equal to.
Are we together?
We are on it.
Okay, sir.
Print,
So remember, we created two variables. We assigned one to the value 1, created another variable assigned it to the value 2. Then we created another variable C and we assigned the sum of A and B. And then we're printing C, essentially telling Python that return the result to us. Don't just store it, return it to us. Okay, Ifeanyi, sir, thank you. I see you have run-ins as well. Yes, it returned 3, correct. I don't want to butcher your name, but Mr. Professor Dan, I believe.
I have done that. I have
You
that.
got 3 too?
Yes, I had 3.
Okay, that's
But how
awesome.
do I open another terminal on the collab stuff?
Another cell.
Another cell, yes.
Okay, so if it's a code cell, there should be if you can see my screen, there's a plus code here. Just
Where is the
click
plus
that.
code?
Up left.
Upper
Upper
left.
left.
Okay.
Yeah, if you can see my screen.
Yes.
Yeah, so just click that.
Okay.
It will give you a new cell.
Okay. I can see that.
Right. Okay, so remember when we did hello world, right? Let's do something. Let's come here and you create any variable. Like we know, by definition, a variable can be anything. Give it whatever name. You can even give it your name. And so let's say, let me give you my name. Well, technically, just give it the first letter of your name. So let's say J equal to, assign hello world to that variable, and let's return that. Any progress? Mr. Thomas, fantastic. Mr. Ifeanyi, Mr. Dan. If you're having any issues, just kindly let us know. Okay. I would assume that silence would mean we're doing well. Isaiah, great job.
Yes,
Yes,
we are.
sir. Okay, fantastic. Okay, so let's do another exercise in variables. Create a variable called statement and write your favorite meal. So you could say, my favorite meal is XYZ, and then return that statement. Let's say my favorite meal is rice, for example. Let me know when you're done. Okay. If I'm going too fast, let me know. Um, okay, Thomas is done. So Thomas is done. Mr. Azar, were able to do this too? Okay, I'm going to assume everyone here is a professor, so I'm addressing everyone correctly.
I finished.
Great, fantastic. Okay, let's do one more variable. Do we have any questions so far? I'll give 1 second for questions, then we'll jump right into more variables. Okay, I will give what to do. I wouldn't type, and I would expect everyone to try to attempt it. If you make mistakes, it's part of the job. In fact, if you have errors, it's part of the job too. So don't worry about it. Create create 3 variables. In your first 2 variables, you want to have 2 numbers. And then your third variable, multiply the 2 numbers and return the multiplication. So let me type um, the instruction. Create 3 variables. The first 2 variables assign unique integers to them. The third variable should be multiplication operation between the first 2 and return the result. So let's say create first 2 variables, x and y, say, assign unique integers to them. Then the third variable, z, should be a multiplication. Okay, so just in case you need the instruction and it wasn't clear, I posted it in the chat. The first person to be done, please let me know. Okay, Mr. Ifeanyi is done. That's fantastic. Thomas is done. Thank you, professors, for being in lockstep with this.
I've finished.
Oh,
Wow.
Great job, sir.
Great.
Great job, sir. How was the experience? Do you want to share your screen so we see what you did?
Okay, let me do that.
Awesome.
Let me share.
Oh, Mr. Professor Isaiah is done too. Thank
This
you
was what
all
I
so
did.
much.
Done,
So you
done.
can share your screen. I could stop sharing mine in the interim.
That's mine.
Okay, okay, this is great.
Okay, that's good.
Wow, wow, this is
Interesting,
lovely.
because I never showed you how to do the multiplication, but that's good.
That's
That's
great.
good.
But once you are
Good.
used to Excel and some of these syntax, you will know that multiplication is asterisks.
Exactly.
Yeah, but that's very good. Very, very, very good.
Okay.
So let's recap what we've done so far. We started by, first of all, printing what we call our first program, Hello World, and then we looked into variables. Remember before we even looked into variables, we looked at within print returns an operation that we've done, right? Um, if if we want Python not just to store it but to return it, we want print to be, our function essentially. Um, so after doing that, we came to look at variables, understanding that you can assign values to a variable. your variable is always on the left-hand side and values on the right-hand side, then you could actually assign variable operations to a variable. So that's what we have here, right? This is an operation that we did, addition, and then we return that. Remember, we saw that if we do not execute the print function on this variable, we wouldn't get any result. So essentially, Python will just be storing the value until we have it spit it out to us, right? Now we looked at the same hello world that we did, made it a lot cleaner by assigning it to a variable and then returning that variable. Then we had a statement, my favorite meal is XYZ, whatever your favorite meal was, and we returned that as well. The exercise came, of course, to return assigned values and then return the result of an operation. I'm sure we've followed so far. So let's keep going. Please, if you are not following, kindly let me know, because as we keep going, the complexity will increase.
Yes, can we have feedback from some other participant, please? It's
Okay.
like only a few persons are responding. We've tried to make it a little bit more easier that even if you cannot have it installed, from your browser, you can start. So can we hear from those who have not spoken at all, please? Let's get some feedback. From those who have not spoken to us at all, can we get some feedback? Okay, let's go on, please.
Okay, sir. Now, before we move into this one, on your last cell, I want you to go. Can you all see my screen?
No, not yet.
Okay, yeah, let me reshare. Okay. Let me know once you can see my screen, please.
Yes, we can.
Oh, fantastic. So come to this top right and click text. A new cell would pop up. Let me know once you've gotten to this point. So here we're going to look at data types. So just type it as basic. What goes into this text are basic alphanumeric. So letters and numbers without any sort of rules, essentially. There are complex rules, but those can be handled much later. Data types. And you do the same thing, shift and enter to run it. If you want to go back to edit it, so once you do shift and enter to run it, if you want to go back to edit it, you could double click it and it should open again, right? Any questions here?
Please, where did you get in?
So to the top right.
Questions. The top right. The top right. Top right. Top right.
So you should see text, click on text, a new cell should open, and then you type in there. Any questions, confusions? Please, we're all doing this together. So if you are successful, just give me a thumbs up. Let me know that you're done. Sort of like how Professor Ifeanyi has been doing. Okay, Thomas is done. Oh, awesome, Professor. Okay. I probably will just ignore this part. Yeah, I don't need that for now. While looking at data types, remember I spoke to you about the different data types. I said we have integers, we have floats, we have strings. Well, within data type, I mentioned that numeric is for integers and floats, and then complex numbers So you know what, let me just make this much easier for us. Numeric, have integers, floats, and complex. Then we have strings, we have dictionaries, tuples, and sets. As you can see, we've already looked at some data types here. Let's start with this. Can anyone take a guess what data type this is? Hello world. What data type is that?
It's a string.
Yes, sir.
A string.
Yes, sir. So how do we know for sure that that is a string? You could just say type. And in this case, we had, let's say, statement, or where we had J as hello world, whichever. String. str is an appellation for string, right? So how do we know it's a string? If it has some kind of yes, I don't know why that word fails me now. Punctuation, um, whatever it's called. What's this called again?
Special characters.
Double quotes.
Quotation
Double
mark.
quotation. Yes, exactly. Quotation. So if it has quotation, it's a string. So for example, let's do this so you see what I'm trying to say. If I say A is equal to, you know, let me make this uniform so it's easier to follow. So I'm going to do it after these definitions here. So if I say A is equal to this, is this an integer or a string? Remember, 2 is an integer, but is this an integer or a string?
It's a string because of the quotation mark there.
Yes, sir. Yes, sir. So you could say, let's check, type A, string. So do it within your computer so that, you know, you won't accuse me of doing rigging something within my computer to make it show that way. Yes, yes. Oh, I really appreciate you all for, you know, being active in response. Um, do you see that as a string in yours? You could even do quotation 1 billion. It still will be a string, right? So now let's do something different. Let's say let Q be equal to 2 and then do type Q. See what it gives you. Are you able to verify that it's an integer? You know, we can unmute ourselves at this point, you know, so it's going to be a bit interactive.
Yes.
Fantastic. Professor Lokwade, I haven't heard from you. I hope everything's okay.
I am actually on it.
Oh,
Okay.
fantastic.
I'm shuttling between the Zoom and the other platform.
Fantastic.
Okay.
Fantastic. Fantastic.
Oh, correct.
Professor Adeni, I see your response as well. Integer, fantastic. So now let's do another thing. Let's say x is equal to 2.0. What type is this?
A float.
Fantastic. So let's assume that Professor Isaiah is not deceiving us. Let's try it out. You know, fantastic. The slogan in mathematics is, you know, you want to trust but verify. You have to verify everything. So we see that that's the flow. Let's try this. 2i. 1 second. We want to do complex numbers now. So let's say, I think it's actually J. Yes. So type Y. Did anyone notice that? Complex. So try that. For those of us that may not be familiar with what complex numbers are, if we are, please forgive me. I just want to cover all bases and do my due diligence. Anytime you have a negative number within a square root, that's a complex number. Yeah. I wanted to gloss over it, but it might be useful in your analysis. You never know.
So
Has anyone been able to verify this?
Yes, I did it, but I noticed that if I just use normal 2i, it won't give me the complex number as the type. But if I use 2j for complex number, then I check the data type, then I will get complex.
Yes, that's why I asked, did you all notice what happened? I had used 2i, and I was like, wait, hold on. I'm seeing that it's going to give me an error. Then I used 2j because I had, forgotten that, not necessarily forgotten, but it has skipped my mind that, 2j is the appellation for complex numbers.
Okay.
Yeah, so the same way we use quotation for string,
Okay.
2j is.
But in normal mathematics, we use the I when solving complex number most times.
Yes. Yes, sir. That's true. Are we good, Professor Lockhart? Everything okay?
Yes, it's okay. I'm good to go.
Oh, fantastic.
Good to go.
Fantastic. You're doing amazing. Professor Adeni, Professor Ifeanyi, how is it looking? Are we up to date with where we are? I'm gonna give a quick second before I jump out of here. So
let's make it interactive as much as possible, please.
Yeah. That's awesome. So we're good. Professor Ifeanyi, everything okay? I'm sorry if I'm calling you by name, it doesn't mean I don't trust you. I'm just, making sure that, I'm doing my job in a way that, satisfies you essentially.
Thank you.
Okay, so assuming those who hasn't responded yet, I would put some of us on the spot shortly. Okay.
That section of comments that you did previously,
Yes, sir.
when you have a long comment, can one also put it in quotation mark when you want to put a long comment?
Yes, you can. So there are different methodologies to actually creating different comments. That is very agnostic to Jupyter Notebook. Okay. So for example, if you want to do headings, if you want to do multiple lines of comments, you don't necessarily have to use quotations though within the comment section. Is let's say when you're doing, okay, let me show you something here. Okay, let me make it a lot bigger. So these are things that, you see, it's much different from how I just type data types here, just by using these two double hash signs. You understand what I mean?
Yes.
Yeah, so there are different strategies to actually creating like cleaner comments. And those are things that would kind of touch on maybe even in the next section.
Okay. Because like this one, what I used here was the markdown to write those the data type, these things you are writing the text here.
Yes, sir. If I wanted to do it within, honestly, to me, this is a lot more cleaner than doing it within. If I was doing this within like Python, this is what I use, multi-line string formatting essentially, where so I'll say like this is a code segment for analysis on XYZ, right? So it doesn't affect my code really, but to me, it's not really as clean as having something like this. You understand what I mean?
Yes, sir.
Yeah. Okay. Any questions? That was a very good question, sir. I really appreciate that. Any questions before we jump up? So we've looked at, there was something I didn't put here, lists. Oh my. In fact, we could spend the rest of the time just studying lists. It's, yeah. So please, can you let me know how much time I have left?
We have 20 minutes before the time.
Okay.
So let's keep going on. I think it's essentially why we are here. So we can use, yeah, go ahead.
Okay. Okay. All right. So now let's look at lists. Now, before we get to list, again, for cleaner code, go to your top left, click plus text, and I'll call this lists. Data type lists. Now, just to go back and make things a lot cleaner, let's come back here and reorder this. Remember, we had done integers. Well, I think we've done strings as well. Yeah. Let's go to list before we go to dictionary. So try to order this in the order in which we're treating them, right? In fact, I'll take all of this out. And let me know once you've done that. It makes it a lot cleaner, easy to digest when you come back to look at it. You'll thank me later. Lists. Lists. Are we okay?
Yes.
Awesome. Okay. What are lists? Did someone say something?
Yes, I didn't get. I didn't quite get.
Okay, let me come back again. I said just, you know where we have this text section of data types? I said, okay, because we had treated numeric data type strings, so, and then the next thing that we're going to treat was lists. I said, just arrange it in that sequential order so that it's easy for you to digest what comes next when you're looking through it.
Okay.
Is that clear, please?
Yes, thank you.
Yes, thank you. Yes, thank you. Okay, so now we want to treat lists. What are lists? Unordered arrangement of multiple data types. So in fact, of multiple data types within a squared bracket. An unordered arrangement of multiple data types within a squared bracket. Plus, it can have duplicates. Are you following? Let me explain that statement. Forget about the big definition that was just given. What are the primary things that we should take from this? If we have a squared bracket with items in it, that's a list. It has to be a squared bracket. Two, within that squared bracket, you don't have to order the values, like say a set, or the values don't have to be unique, like say a set. Sets always have unique values, right? So it can have duplicates, it doesn't have to be ordered, and it could have multiple data types. So you could have a float in a list, you could have an integer in a list, you could have a complex number in a list, you could have a string in a list. Understood? So let's jump right into it. I'm assuming there's no questions, but if there are any questions, just stop me. Let's call this my list. Okay, before we even go further, do not name your variables in this way. I should have said that in the beginning, but it just came to mind. Don't use a capital letter for your variables. If you use multiple words for your variable, do not use space. You can use an underscore. You can use a hyphen. No, I don't even use a hyphen. Just use an underscore or leave no space. But don't use an uppercase. Don't start your variable naming with a number. I'm giving us time to actually digest that. I'll repeat. Don't start with an uppercase or a capital letter. Do not start with a number. 3, if you are using multiple words like my list, do not put a space between them. If you do not put any space between them, if you want something to tie both of them together, you want to use an underscore. And don't use keywords for your list. I hope we're taking note, please. Don't use keywords for your list. So for example, you can't have your list, I say for your list, for your variables. You can't call your variable print. Print already performs a function. You can't call your variable type. Type already performs a function. You can't call your variable list. List is a keyword. Does that make sense?
Yes.
Yeah. It's okay. Mistakes can be made, but if those mistakes are made, it helps you to be able to trace them. So my list, square bracket. Let's start with, this should be fun. If you are going to the grocery market or the market to get some food, what are the list of things that you get? Remember, it will be strings. So I'm going to put my list there. You put your list, and then we're going to have a volunteer essentially tell us what their list was or is. Okay, so I like potatoes a lot. So I'll say some potatoes, eggs, of course. Let's say bread. So you're doing like your top 5 list. Butter, and let's say some, yeah, let's say some cookies. Yeah, keep it simple. When you're done, run it. Let me know who wants to share their top 5 list. Professor Lokwadi, how are we doing?
I am on it.
Fantastic. We can unmute our microphones here. It's going to be, very interactive as we round this off. Anyone done? Don't worry, we're not going to judge your food list, I assure you. Let's just see how you run yours, what you named your variable, or whatever the case may be. Anyone done yet? List of 5 things you'll get in the market if you're to go to the market right now. Professor
Yes,
Thomas.
I'm done.
Oh, who was that, please? Professor Isaiah? Okay, fantastic. So let's share. Can you share your screen? And let's see what you did.
Okay. Can you see?
Yes.
Can you see?
Yep.
Okay. Okay.
This is fantastic. Okay, so yes, you've run that. While you are on here, return my list. Remember, we had mentioned how that there's a way to have your list, Python return your list. So return it. Let's see what we have. And I love how you named your variable, your list, I should say, your variable name.
I didn't quite get how to return this.
Quite get how to return.
So just print.
How to return.
So print and then your variable name.
Okay.
Remember parentheses? Yes. No, you don't have to put a quote on it anymore
Okay.
because that's a variable name, it's not a string. Why are we having that error? Look closely. Let's read the error
Because of
first.
the
Fantastic. Fantastic. Did everyone get that? So essentially, his variable name was uppercase L, but when he was printing, he used lowercase l. Python couldn't find that. Python would automatically find it for you, so you have to ensure that that's consistent. Is there anyone that want to share their screen? Thank you so much, Professor Isaiah. That was fantastic. Is there anyone else that wants to share their screen? Professor Lokwade, do you have something for us?
Yes, I am good to go. I got it correctly.
Okay, so kindly show us what you have.
So that's it.
Good, good, good. That's fantastic. Fantastic. Rice, semo, pepper, vegetable. I like that list. Anyone else want to? Thank you so much, sir.
Okay.
Anyone else wants to quickly share theirs? We have a few minutes. We'll do one more thing before we end for the day, or two more things, I should say. Oh, Professor Ipomosa,
I can
this is
share my.
good. Yes, I can see it. Could you magnify it, please, so I see your screen wholly? Okay, okay, fantastic. That's very good. Okay, so let's quickly jump to the next. I really appreciate you all. You guys are doing amazing. So let me share my screen again, and then we'll bring this home for today. If you can see my screen, just give me a thumbs up or just let me know you can see my screen.
Yes, we can.
Yes.
Fantastic. Okay, now let's do this. Let's call this, you can call it what you want, but I'll call it multi-list. In this list, the challenge is create 2 strings, 2 floats, and 2 integers within the list. I'm not going to do it. I'm going to give us 1 minute to try and do it on our own.
I can't get what you said.
Okay. So within your list,
Okay.
you know, let me make it easy. I'll have us do the next one. So within this list, I want to create one data type, that one value whose data type is a string, one whose data type is an integer, one whose data type is a float. So let me put my name here. So
we can't see your screen. Your screen is not shared.
Oh, that's interesting. Oh, I'm sharing my screen. You sure you can see it?
I can't see it.
Okay, let me share it again. Let me know if you can see it now.
I cannot see it. I can see it.
Can you see it now?
Yes, we can.
Oh, okay, good. So, okay, so everyone can see it. That's good. So I'm going to put my name. Let me put my age. Let's see, what else? What else? What else? Another string. Let me put my last name. And
I hope it will not be affected. The 32 doesn't have parentheses.
no, it wouldn't be. That's the whole idea. So that's the value for pi.
So you can ignore using the parentheses, or you use it
Inside the list. Remember
Okay.
our definition of a list. An unordered arrangement of multiple data types. Like you could put multiple data types inside of it.
Okay.
And what else am I missing? We've done float, integers, and that. So this should be sufficient for now. You see, there's no error. Let's print this.
Please, I can't still see your screen.
You can see my screen?
Yes, I can only see your face.
Okay, please can you confirm who else cannot see my screen? Okay, I'm going to stop sharing and share again.
And that'll be fine.
Okay, can you see my screen
Yes, I
now?
can.
Fantastic. So this, if you see, this is a string, this is an integer, this is a string, this is a float, this is a float. Everything fitting into one list. I didn't have to order it. I could change the arrangement of this list without it giving me an error. So if we check the type of this, you realize that it's still a list. As far as it has the square brackets, it's still a list. You see what it's giving us down here? So the final challenge for the day, try to have your name within a list. You don't have to put your age. You can even put, okay, put integer 100 within the list. So your name, first name, last name, let the first name be separate, let the last name be separate. Put your, put 100 as integer, and then put the value of pi, 3.145 approximately. And let's see who has that. I'm going to stop sharing so no one copies my work. Yeah, and that's where we'll kind of, before we finish, once you're done with that, I'll kind of talk about what we'll potentially do next week um, to kind of crown this essentially. Anyone done?
So what's the last assignment? Is this still on the multi-list?
Yeah, that's the multi-list. Yeah, that's it.
Okay, I've been able to do mine.
Oh, fantastic. Share it. Let's see.
Though I battled with it, I had some errors, but eventually I was able to surmount that.
That's good. That's amazing. Can we see it?
Okay, let me share.
Yes, sir.
Wow. So that's it.
Okay, it's still pulling up. Oh, fantastic. You even added complex numbers. I love it.
Yes. So the problem I had was that I didn't put the parentheses for the Olokpa day. So it was complaining.
Yeah, that happens to the best of us. Don't worry about it. But that's very good.
Okay.
One suggestion. So when you're creating lists, it's often better for readability to keep space between each item. So just space it out inside your list. So even if it's just one, yeah.
I can see the print has spaced it out.
Yeah. So but when people are reading your code, it's easier for them to read it when there's like space. You understand?
Okay.
Yeah.
Okay.
Yeah. So I'm guessing we're all doing well with that. So I'm going to share my screen again to let us know some of the things that we'll touch on next week. We'll do more hands-on work next week as well. More hands-on. Before I continue, can everyone see my screen?
Yes, we can.
Okay, so we'll do more hands-on examples next week, but then we'll try to use some libraries for like some foundational concept thing. So these are 3 things that we're going to do. Next, we're going to try to simulate quantum states. So we'll do some more exercises first to get us sharp. Then we'll try to simulate some quantum states and try to solve like the Schrodinger's equation. And then we'll try to visualize like quantum states within the with Bloch sphere. We'll do 2 visualizations. Yeah, we'll do those 2 visualizations, and then we'll have some key takeaways after that. I wrote the scripts for that already. I was going to kind of showcase it, but we'll do that next week so that we can all get along and no one feels left out. I don't know if there are any questions, so I'll stop here for now.
Yes, thank you very much, Doc. Please, you said next week. Oh, are we going to do it?
Oh, I said no. Sorry, not next week. Next time, next session. Sorry.
Okay.
I'm sorry. Next session.
That's great. Thank you. Yes, any question? Thank you very much. Can we give a round of applause, virtually, physically?
Sorry, sir. I have a question quickly before we round off, sir.
Yes. Can we appreciate him first?
Thank you very much.
Thank you.
Quite
Thank you
appreciative,
very much.
and we thank you so much for sharing the knowledge.
Thank you. Okay, so let's take maybe a few questions very quickly. I think you can raise your hand so that let's make it a little bit. Someone was speaking earlier, so you can unmute yourself and speak. Okay, I saw I'm seeing Jonathan. Okay, you can unmute yourself and speak. Jonathan Chuku, you can unmute yourself and speak, please. Okay, the hand is down. Any other question again from anyone?
Sorry, Prof. I was just trying to
clap for
go
him.
ahead. Start clapping.
Okay, thank you.
Yeah, thank you.
Any other question again?
Yes, sir. Thank you, sir.
Yes, please go ahead or meet you.
Yes, sir. I joined the class very late. I don't know if I can have access to the recorded version so that I can study it before the next class.
No problem. Are you on our platform?
No.
No, Professor Lainga is not on the platform. He is currently my doctoral student. I gave him the link day before yesterday to join the stuff.
Okay, so what I will do now, I'll quickly share the link to our WhatsApp group so that everyone who has not joined that platform can join right away. I will also add a resource person so that he can also attend to some of our challenges, maybe if he is disposed, whatever challenges we post on the platform.
Absolutely.
I'm going to be doing that right away. So that let's join the group so that the conversation can continue on that platform. Okay?
Yes.
Okay.
Also, a provision for some soft copy Python books with around machine learning for
yes, you
quantum
promised
physics.
to give to Prof.
Yes, it will be sent to him before end of day today.
Okay, thank you very much. It's quite appreciated.
Thank you so much, sir.
Yeah, at no cost, please. At no cost.
Thank you so much, sir. So you have the link to join the WhatsApp group already on the meeting chat. I'm also
thank you, sir.
For those who are there, I want to share with everybody who join the platform. Okay. Any other question for our presenter? Okay, so we're already 4 minutes behind schedule. I want to say a big thank you to our presenter. I believe it was a very refreshing experience for each and every one of us. Even for those of us who have been programming in Python, I must say it was really a wonderful experience for us. And we are looking forward to the second edition last Saturday of the month. But meanwhile, please, all those material that you will share, you also think of any hands-on activity that participants should get engaged in before the next session, please don't hesitate to share with us, please.
Absolutely. I created a Jupyter notebook that has about 10 questions around some of the things that we've treated today. 10 to 18 questions, I believe. That will be shared as well. Here's what will happen. If you don't have Jupyter on your system and you're having issues with installing, we'll try to attend to that during through WhatsApp. But let's assume all else fails, worst case scenario, we can use Google Colab to answer these questions. You can just copy and paste them and, solve.
That's great. That's great. Thank you very much. Thank you very much
Yes,
for that. Okay.
Yes, sir.
A very quick one, please, everyone. Once again, I want to say thank you for each and everyone for making our time to be here. Especially, I want to appreciate my own brother and Professor Lopade, who has been one of the key driver of this process. Automatically, Professor Lopade is part of the stakeholder in this program. And then I see him as part of the co-host as well, because his efforts towards this has actually been very remarkable. Prof, I really appreciate you.
It's
And
my pleasure.
I'm not taking your presence here for granted, honestly. you are such a motivation for this kind of a meeting. Thank you so much. God bless you, Prof. And to everyone, I can't be mentioning everybody's name. Adele, Yadewopo, Danladi, Isaiah, Jonathan, my own very dear brother. Everyone, please. I celebrate and appreciate our time in this particular adventure. The whole idea is for us to actually become better than who we have always been. And believe me sincerely, the sky cannot even limit us, because we can actually go far to actualize our goal. But please, you will still give me like 3 minutes. 3 minutes, please. I believe it shouldn't be more than that, in order to be able to give honor to the sponsor. Like we've always said, we don't really have finance running this program. But my opportunity as a Fed fellow has given me this Zoom platform. If you know how much you pay for a premium Zoom account, it's not a child's play. We can't afford it in this part of the world. And so being a fellow of a Fed Interactive Simulation, a program I was part of, and I even got a commendation from, I feel I should also let some of us know about what it is. And today I will just share my screen for about 5 minutes, and then please pay attention. I'm not going to take too much of your time. I will just show you just one or two things, how you can also make use of this to be a better professional, a better teacher, a better lecturer. So just bear with me as I share my screen with you very quickly. So I believe you can see my screen. So the website is PHET, phet.colorado.edu. That is the website of the PHET Interactive Simulation. Somebody will be asking me, what is PHET? What is PHET? PHET actually stands originally for Physics Education Technology. It was an initiative conceived by a Nobel laureate winner by the name Carl Wieman. When he won the Nobel laureate, he thought of what he would do. And what he did was to simply start this initiative to teach physics using simulation. They've delivered over 1 billion simulations over the years, and the project has won so many awards. It's located at the University of Colorado in Boulder, and they are the one that gave us the opportunity to be able to actually have this platform to engage in this scientific activity. Now, these simulations are available even in so many languages, including some major Nigerian languages. So you can see translated sim here. You can access them. I'm trying to open it another tab. You can access them. But all you have to do to be able to have full access is for you to first of all actually register on this platform, okay? Once you register and sign in, you have access to some premium facilities on this platform, okay? I will demonstrate just one of the sim today, which talks about vector. You can actually have access to this sim both online and offline. meaning you can download it and use it on your computer. To be able to have access to that, you have the download session down where you can actually go and download the offline session. This we have the offline session down this page. Once you click this, maybe I should even copy this link and paste it for us on our charts quickly, so you can actually have access to this. So you can have access to the offline version of that simulation. Okay. Now I want to just demonstrate one, and that is vector. Vector. I will just show us a few things there, which I believe we can engage more effectively at our own leisure time. We can also access any of the sim by simply searching for them online. Okay. Vector, vector, vector. I'm trying to look for it. Vector addition. Okay, this is vector. I have vector equation, vector addition, either of the two. Let me just pick this one. So the sim can also be downloaded as a single. We can have it downloaded here as a single file that can be run offline. It can also even be embedded to your personal website. You can also have it added to your Google Classroom if you use that. And you can run it right here on this page. And that is what I'm trying to do now. Okay, so with this, we can actually use this as a learning tool to teach our students various things about sim, and we can display the value, various angle, and then we can actually do more. The beauty of all this is that if you go back to that page, we have a lot of material that have been prepared as a form of a guide on how to use each of these sim. As we can see, each of these vectors without displaying the full components. Okay, let me remove these values. Okay, and then if I didn't display anything, it's just I have a single vector, a vector B. And if you come up here, you can see that the B has both the magnitude of this, and it has an angle of this. Okay, this is the X and Y component of this vector B. If I select vector A has just A component. If you look at it from this Cartesian coordinates, you can see that we don't have any S component, which is 0. We have a Y component of 5, okay? And you can see, if you look at it from the polar coordinates, you have A is equal to 5 and you have your theta is equal to 90 degrees. And so much more can actually be done. We can combine vector and actually have a real practical experience of how this thing works. We don't have time for all this. Maybe one of these days we might also go into detail on looking at some of this and how we can leverage on them. And on that note, I want to say a very big thank you to everyone once again. And I want to say a big thank you to our sponsor, PhET Interactive Simulation, University of Colorado, Boulder, USA. Thank you to each and every one. And I want to say, have a lovely and a blessed weekend. Bye for now.
Thank you very much, sir.
Thank you, Prof.
Very, very good.
Thank you, everyone.
Thank you so much, Prof.
Thank you, sir.
Really
Thank you
appreciate
very much.
Thank you.
Thank you.
Thank you, Prof.
Thank you, sir.
Thank you.
Thank you, sir. God bless you, sir.
Amen. You too.